So in the yesterday's class, we discussed the important points which are to be remembered while solving problems on non-concurrent force systems. We are going to use three equations of equilibriums, and we are going to stress on the free body diagram and solve that free body diagram for reactions by using three equations of equilibrium. And this free body diagram is going to have all the forces which are acting on the beam along with reactions which are placed in place of support. So we know that roller support has only one vertical reaction, hinged support has two reactions, horizontal and vertical, whereas fixed has horizontal vertical reaction along with the movement to restrain the beam from bending. So we shall take a simple problem. So we can see that there is a simply supported beam of total span 5 meters, which is loaded as shown in the figure. You're supposed to find out the reactions at A and B. A and B. Now, the first thing what you're supposed to do is you're supposed to draw the free body diagram of the given question. And we all know that free body diagram consists of self-weight, action, and reactions. But in this case, as we have discussed, we are not going to have the self-weight of the beam. So that is neglected. So basically, we are going to have only two terms, that is actions and reactions. Now, actions are those which are externally acting on the beam. So we can see that there is a beam AB which is influencing 3-point loads, which are acting on it. So basically we have three actions. So when we look at the loads, I've told you that the loads should either be vertical or horizontal. If not, you're supposed to convert them to horizontal and vertical loads. But in this specific problem, we have only vertical loads and we are going to show it in their position only as we are shown it in the free body diagram. So actions are being displayed. Now the next thing is reactions. What are reactions? Reactions are nothing but they are the substitution for the supports. Now, as you all can see, the support at A and B, what type of support is it? It is a hinged type of support. Now, we all know that a hinged support has two reactions, one vertical and one horizontal reaction. Now, in this specific free body diagram, we see only the vertical reaction and we do not see any horizontal reaction. The reason being there is no horizontal force acting on this beam. So since there is no horizontal force or there is no horizontal action, therefore horizontal reaction will be 0. And since we have only vertical actions in the diagram, so we have only vertical reactions. So this RA and RB, which are substituted in the place of supports at A and B. Now, one more important thing which is to be kept in mind is whenever you are providing the reactions, the direction of the reaction are initially assumed. So once you calculate the answers for those reactions, then you will come to know whether the direction of the reactions are correct or not. Okay. Now, this is the free body diagram which consists of actions and reactions. Now I need to solve for reaction at A and reaction at B. Now we know that the reactions are solved by using three equations of equilibrium. So those three equations of equilibrium are sigma fx is equal to 0, sigma fy is equal to 0, and sigma moment is equal to 0. Now since in the present problem we do not have any horizontal forces, we are not going to use sigma fx. We are going to use the other two equations of equilibrium. So let us use sigma fy is equal to 0. So what is sigma fy is equal to 0? It is resolving all the forces in vertical direction. vertical direction. So we shall write the equation for sigma Fy. So you can, while writing the equation, just refer the free body diagram. Free body diagram. We know the notations for sigma Fy, that is all the forces moving upwards are taken with positive sign, all the forces moving downwards are taken with negative sign. So the first reaction we are going to consider, so Ra, which is acting upwards, so it is taken with the positive sign. Next is reaction at B. Reaction at B also is acting upwards, and that is why we are taking Rb also with the positive sign. Whereas 6 kilonewton, which is the vertical force moving downwards, is taken with the negative sign. 2 kilonewton acting downwards with the negative sign. 5 kilonewton force acting downwards also taken with the negative signs. So let me just count the number of vertical forces in the free body diagram. There are 1, 2, 3, 4, 5 vertical forces, and in equation of sigma Fy also I have 5 components. 1, 2, 3, 4, 5. Always make it a habit to count the number of forces in the free body diagram and in the equation so as to avoid skipping of any of the force. Now, when we rearrange the terms in this equation, we can write this as Ra plus Rb is equal to 13. So all these minus 6, minus 2, minus 5, which turns to be minus 13 on the left hand side, it will go on the right hand side to become positive. So Ra plus Rb is equal to 13. So we cannot solve this equation. So Ra plus Rb is equal to 13. Therefore, we have two unknowns. Let us keep this equation as it is, and let us move on with the next equation of equilibrium, that is sigma moment. Now, sigma moment, whenever you are taking, you're supposed to take either at point A or at point B, or in general terms, if I have to tell you, always choose a moment center in such a way that most of the unknowns are passing through that point. I repeat, choose the moment center in such a way that most of the unknowns in the sense reactions, are 0. Now, if I take moment at point A, so I'm going to take moment at this point, A. The next question what I'm going to ask myself is, total there are how many forces? So 1, 2, 3, 4, 5 forces. Amongst 5 forces, how many forces passes through the moment center? It is only one force, that is reaction at A. So how many forces are left out? 4 forces are left out. So I'm going to have 4 components in my moment equation. I'm going to have 4 components in my moment equation. Okay. Now, starting with the first one, we know the rules for applying the moment. That is, if the force is vertical, the distance to be multiplied is horizontal, and if the force is horizontal, the distance to be multiplied is vertical. Now, by applying the same theory, we shall continue this. So the first force is, let us take Rb. So Rb is a vertical type of force. So the distance to be multiplied is obviously horizontal distance. So what is the horizontal distance between A and Rb? So it is 2 plus 1, 3 plus 1, 4 plus 1, 5. So it is Rb into 5. What type of movement is it causing? So I have told you to use your 2 fingers, that is your thumb and the forefinger, and move one of your fingers in the direction of force. So if you do so, you will see that Rb is causing anti-clockwise movement, and that is why it is taken with the negative sign, that is minus Rb into 5. Now next, 6 kilonewton. So again, this 6 kilonewton is a vertical force. Hence, the distance to be multiplied is a horizontal distance. And at what distance is 6 kilonewton acting from point A? It is acting at a distance of 2 meters. 2 meters. So it is 6 into 2. Now, next question is, what type of movement is it causing? What type of movement is it causing? So the thumb on the movement center, move your forefinger in the direction of force, that is 6 kilonewton, and you find that it is causing a clockwise movement. Thereby, we take it with positive sign. So it is positive 6 into 2. Similarly, we have another force, that is 2 kilonewton. 2 kilonewton. Again, 2 kilonewton is a vertical force. Distance to be multiplied is horizontal. So always keep one thing in mind. The horizontal distance is to be measured from the movement center. So the distance of 2 kilonewton force from movement center is 3 meters. Is 3 meters. So it is 2 into 3. 2 into 3. Now next is, what type of movement is it causing? So again, if you just happen to keep your thumb on the movement center and movement of your forefinger in the direction of 2 kilonewton, you find that it is causing a clockwise movement, and thereby it is supported with the positive sign. It is supported with the positive sign. Now next, the last force, that is 5 kilonewton, which is again a vertical force. Vertical force. So the distance to be multiplied is obviously a horizontal distance. So this 5 kilonewton force is at a horizontal distance of 2, 3, 4 meters from the movement center. So that is why we have written 5 into 4. The next question is, what type of movement is it causing? What type of movement is it causing? So the movement of 5 kilonewton is again a clockwise movement, and that is why we have taken the positive sign. So in whole of this equation, we can see that it is only RB which is unknown, If we solve for this RB, we get RB is equal to 7.6 kilonewton. 7.6 kilonewton. Now we know that the equation in the previous equation, that is equation of equilibrium, that RA plus RB should be equal to 13. So therefore, if you substitute the value of RB in place of RB in the equation, so you will be easily calculating what is reaction at A. Now, just pay attention on these reactions, that is RA and RB. Now, you can see that when you calculate the reactions at A and B, you found that the values of these reactions are positive. Now, what does reaction RA and RB, if you get it positive, it means that the direction which you have assumed in the free body diagram is correct. I repeat, direction of reactions are initially assumed in the free body diagram. So once you calculate for those reactions, if you get the answer with positive sign, it means that the assumption is right. In case if you get the reaction with the negative sign, it means that the direction of the reaction is to be changed. But you're not going to change the direction of reaction until and unless you complete the problem. So once you complete the problem, then only you are going to judge on whether the reactions which you calculated or the assumptions which you had made is correct or no. So this is how a simple problem on a beam is solved, wherein you have calculated the reactions at A and B.